Hello, everybody. Welcome back. My name is Michael. Hope you're having a wonderful day so far. Today is February the 6th, 2025, and we are back learning some Python today. Hope you guys are having a great day today. Let me know what's going on. What's new with you guys? Welcome back to the channel. Hello, Mahan. Welcome back. Awesome to hear from you. Wait, thanks for jumping in here with me. How's it going? All right. So last time we left off on chapter 9 on heaps in 9.3 uh, for dealing with kind of priority queues. And now we're going to talk about actually implementing a priority queue with a heap. Yeah, let's go ahead and dive on in here. Okay. Proposition 9.2 has an important consequence, for it implies that if we can perform update operations on a heap in time proportional to its height, then those operations will run in logarithmic time. Drinking some lemonade. That's just my kind of go-to. I get it at the Costco here. So height h and height of a tree of t. A heap storing. So heap. So heap is a binary tree that stores a collections of items at its positions, and that satisfies two additional properties. A relational property defined in terms of the ways keys are stored in the tree. Heap order property. So what exactly was a heap again? It was a tree. Heaps, two binary heap. Okay, yeah, that's right. Hey Ryan, I remember yesterday I saw a glimpse of CS50 and you were writing in C. Does he switch between different languages a lot during the course? No, for the first 5 weeks you entirely write in C, and then in week 6 is the first time we'll ever start to write in a different language with Python in CS50X. So the first 5 weeks are all in C, but we're just taking that course on the side here of our normal studies through the readings and stuff. Okay, so simply describe a heap. A heap is a special kind of binary tree where the parent node always has a specific relationship with its child node. Max heap, parent is always greater than or equal to its children. Min heap, parent is always, okay, right? Okay. Okay. We will use the composition pattern from section 9.2.1 to store key value pairs as items in the heap. The length and is empty methods can be implemented based on the examination of the tree, and the min operation is equally trivial because the heap property assures that the element at the root of the tree has a minimum key. The interesting algorithms are those for implementing the add and remove min methods, adding an item to a heap. Let us consider how to perform add, key, and value on a priority queue implemented within a heap tree. We store the pair, the key, and the value as an item at a new node of the tree to maintain the complete binary tree property. To maintain the complete binary tree property, that new node should be placed at a position P just beyond the rightmost node at the bottom level of the tree, or as the leftmost position of a new level. In the bottom level, if the bottom level is already full, or if the heap is empty, right, gotcha. Uh, Up heap bubbling after insertion. After this action, the tree is complete, but it may violate the heap order property, hence, unless position P is the root of the tree, that is, the priority queue was empty before the insertion, we compare the key at position P to that of the parents, which we denote as Q. If the key at the parent is greater than or equal to the P at Q, we compare the key of the positions to that of the position's parent, which will denote as Q. If the key of the position, current position, is greater than or equal to the key at the parent, the heap order property is satisfied and the algorithm terminates. If instead the key at the current position P is less than the key at the parent Q, right, key, then we need to restore the heap order property. So I guess you'll automatically insert and then just evaluate to the parent node. Are you greater than or equal or less than the parent? If you are, then swap. If you are less than, then swap, basically. And you'll kind of bubble up the tree swapping nodes every time if you're less than with the parent. Okay, got you. Um, this swap causes the new item to move up one level. Again, the heap order property may be violated, so we repeat the process going up in the tree until no violation of the heap order property occurs. The upward movement of the newly inserted entry by means of swaps is conventionally called upheap bubbling. A swap either resolves the violation of the heap order property or propagates it one level up in the heap. In the worst case, upheap bubbling causes the new entry to move all the way up to the root of the heap. Thus, in the worst case, the number of swaps performed in the execution of the method add is equal to the height of the tree by proposition 9.2 that is bound. That bound is floor of log n. Okay, so we'll go here. We'll say adding item to heap, right? So we'll say this for this guy. A new node with a key value, right? A new node with a key value pair will be created and either inserted at the rightmost position on the lowest or the furthest depth, or if the lowest depth is full, insert at the leftmost leftmost position on depth plus 1, right? So adding an item, a new node will be inserted with the key value pair, will be created and either inserted at the rightmost position on the furthest depth or the leftmost position if that at the depth plus 1, a new level, right, a new lower level. And then we'll say this satisfies the binary tree structure, but we must evaluate the key of the newly inserted node with the key of its parent, right? If the key of the newly inserted node is less than the key of the parent, swap nodes. This is going to be bubble up, aka up, heap, bubbling. Okay, right? So I'm going to take this, I'm going to throw this into the almighty orb and see what it spits out at me here. Perfect description, just add a little bit of clarity. Insertion process. In a heap involves two main steps. Inserting at the rightmost available position at the lowest level, maintaining complete binary tree structure. Up heap bubbling, comparing the newly added node with its parent node and swapping if necessary. This continues until the heap property, min heap or max heap, is restored. Got you. Sweet. Hey Tim, welcome. How's it going? Hey LOL, welcome back. How's it going? Appreciate you jumping in here for a sec. All right, so we have example here of A. We have a new node with a key of 2 and a value of t being inserted in at the most available position. Well, the most available position is the left child of this node here, 20 and B. So we insert there, and then we evaluate. Okay, the 2 key is less than the 20 key. We need to swap these nodes or the elements at these positions. So we swap, right? Swap, and that so is there. The 2 is less than the 6 here. In this key, we swap again. The 2 is less than the 4. We swap again, right? So what would happen if you tried to insert a 2t like over here? It would cascade all the way up, moving the 4 here, which would be less than the 2. I guess that would still be satisfied, so it still would work. Okay, gotcha. All right. Nice. So that key that we inserted, or that new bubble, right, or that new value node, bubbled all the way up our tree. Removing the item with a minimum key. Okay. Removing item with minimum key. Let us now turn to a method remove min of the priority queue ADT. We know that an entry with the smallest key is stored at the root R of the tree, even if there is more than one entry with the smallest key. However, in general, we cannot simply delete node R because this would leave 2 disconnected subtrees. Instead, we ensure that the shape of the heap respects the complete binary tree property by deleting the leaf at the last position of the P of the tree. Okay, so you delete the leaf Instead, we ensure that the shape of the heap respects the complete binary tree property by deleting the leaf at the last position P of the tree, defined as the rightmost position at the bottommost level of the tree. To preserve the item from the last position, we copy it to the root R in place of the item with minimum key that is being removed by the operation. Figure 9.3a and b illustrate the example with steps with minimal item. 4c being removed from the root and replaced by item 13w from the last position. The node at the last position is removed from the tree. Okay. And then you down heat bubble from there. Oh, okay. That was going to be my next question, is how do we maintain the order then? Okay, got you. So you down heat bubble after swapping the node and just swap all the way, going bubble down. Interesting. Okay. Right. So we are not done yet. However, for even though T is now complete, it likely violates the heap order property. If T has only one node, the root, then the heap order property is trivially satisfied and the algorithm terminates. Otherwise, the distinguished two cases where P initially denotes the root of the tree. If P has no right child, let C be the left child of P. Otherwise, P has both children, let C be a child of P with a minimal key. If the key at the position that we're currently on, which is the root, is less than the key at the position of the child, the heap order property is satisfied and the algorithm terminates. If instead we have the inverse, where the key at the position we are on, the root, where we newly inserted the last node for the minimal removal of the, priority queue, um, then we need to restore the heap order property. This can be locally achieved by swapping the entries stored at P and C. It is worth noting that when P has two children, we intentionally consider the smaller key of the two children. Not only is the key of the child smaller than that of P, it is at least as small as the key at what? Not only is the key of the child smaller than that of the position, or the parent in this case, it is at least as small as the key at child's siblings. Yes, right? So the leftmost, if you evaluate the leftmost condition, you don't need to evaluate the right condition, because if you satisfy the left condition, you will satisfy the right condition by default, because you automatically will be left. So if you don't satisfy the left one, then you'll go and check the right one. Got you. This ensures that the heap order property is locally restored and that the smaller key is promoted above the key that has been at the position that at child sibling. Having restored the heap order property for node P relative to its children, there may be a violation of this property at child. Hence, we may have to continue swapping down T until no violation of the heap order occurs. This downward swapping process is called down heap bubbling. A swap either resolves the violation of the heap order property or propagates it one level down in the heap. In the worst case, an entry moves all the way down to the bottom level. Thus, the number of swaps performed in the execution of the method remove min in the worst case equals to the height of the tree heap, and that is the floor of log n by prop 9.2. Okay. Hey, Script Serpent, welcome back. I appreciate you joining me here. I've been playing around with Warzone with my homie, and I've got a dub. I've just been waiting on him currently, so I'm like, I'll stop by and see what's up. Nice. I used to play Warzone a lot with some of my friends back in the day, from high school and back home. But ever since I sold my PC and they did too, we just haven't really played it ever again. And I would just get so mad though. I was definitely a rager. That was for sure. I'd get mad and I would talk a bunch of trash, and it's fun though. All right. So removing an item, when invoking the remove min method of the priority queue ADT, this will remove the root node, the node with the lowest key value. To maintain the structure of the binary tree heap, the last node that or in the tree, the node in the rightmost position at the depth equal to height right? Um, so here we go. So it says rightmost position at the bottommost level. Bottommost level. Is copied to the root. Is copied to the root position that was just removed. And a down heap bubbling occurs, swapping key value nodes where the copy was just removed, and a down heap bubbling occurs, swapping the nodes where the root or the parent key is greater than its than the left child. Okay, let's take this into the orb. All right, almost there, but a couple of clarifications. We will tighten this up. When you remove the minimum, remove min in a min heap, you remove the root node because it has the smallest key. The last node, rightmost node at the lowest level, replaces the root to maintain the complete binary tree structure. Then you perform down heap bubbling, also called heapify down or sift down to restore the heap order property. During this process, the node swaps with the smallest child left or right until it's smaller than both. Okay, I like this definition a lot better than mine. We'll take this one. We'll take this one and go right like that. Cool. Hey Tim, welcome. Mr. Demi used to be a gamer now. He's locked into the studies now. When we hit 100K subs, he'll share his craziest party story, I'm sure. That's funny. Yeah, I went to some parties back in, at Utah State. It was fun back when, just had less cares and less not being adulthood to worry about, I guess. But that's in the past now. I'm moved on from that. Just more of a keeping it chill. And thank you so much, Tim. Yeah, I appreciate it. Yeah, it'd be crazy when we hit 100,000. Well, we got to do that 99 more times here. So hopefully we'll do it. Warzone I always carry while me and my homies talk, which is funny because both get banned. Nice. This is me and my bro saying this. That's funny. Maybe if I ever get back into it, we can play a game or something. I have to maybe, if I ever decide to get a console or a PC or something in the future, we'll see. Maybe after I can accomplish my software engineering goals here, we can do that. But we got a lot to learn here. Okay. Yeah, so you pop off or remove the root position, which happened to be the lowest key, right? The root movement. We take the node at the last position, 13W, and put it at the root. We then do a down heap bubbling to propagate or pretty much propel this node downward to satisfy these conditions. So, Gotcha. So you are, in this case, you're at 13W. You're less than here, so you have to evaluate here and swap. Yeah. Remove all the entry. Got you. Sweet. So that makes a lot of sense to me. I get that. That's not too bad. Everybody else feel kind of okay with that one? Thanks, Grip Serpent. I appreciate your willingness to put me on your back. All right. That's what she said for sure. All right. Array-based representation of a complete binary tree. All right, here we go. LOL. This is what you were talking about earlier of array-based representation. Okay, so we'll go here. We'll go array-based representation. Let me know what you guys are working on. I appreciate you guys, coming in here and joining me and following along. Let me know if you're just watching along here with the actual stream, and let me know if you're, keeping up here with the notes, or if you're just have the stream on in the background and you're doing some studying. That's also a great way to hold yourself accountable. I try my best and have been streaming every single day for the past, over 2 months. So I have the ability to maintain a streak here and hold myself accountable. So if you're struggling with something like that, then join me here daily around 7 p.m. PST to do some studying and just have the stream in the background to hang out as if we were just in like a study room back in college where we booked a library room and we're just hanging out, doing our homework together and being productive. So thanks so much for joining me here. You don't have to be, following along directly, but if you hear something that, sparks that chimes in your ear and you're like, oh, I wanted to learn about heaps, you can tune in and listen. And yeah, thanks so much for joining me. Now you have to play with him. He doesn't respect your game. I wasn't that. See, my calling back in the old COD days when I would play back growing up was I just loved sniping. I don't know what it was with sniping, but I was all about snipers. So whenever I play Warzone and stuff, I always go for snipes and try to like. I am kind of like a camper. I kind of play it like more, not realistic because it's not realistic at all, but like I like to kind of sit back and like on the building tops or trees or bushes and or like hilltops and kind of play the distance game and pick people off. I think it's fun that way. You're making me want to play that game. I haven't played in a while. I used to be really big into League of Legends too, honestly. I'm not ashamed to admit that one. I grinded League for a while, I sucked up in my silver ranking or gold or whatever I was, not very high. But that game just sucks you in so bad. You play so much once you start. But I haven't been able to play any games like because I have a Mac, so because it doesn't really run. It can run League of Legends and Minecraft pretty fine, but I don't have a good mouse. I have this crappy Apple mouse, and um, so we'll see if I get a better mouse. If I can, I wanted to maybe play some Minecraft with you guys, like on a Saturday night or a Sunday night, as just like a chill late night session, and just maybe we could open a realm and try to like defeat the Ender Dragon in one night or something, or that'd be kind of fun. Let me know if that sounds like something you're interested in. Long range threat. Yeah, I used to do all that like sniping and 360s and stuff back in the old Modern Warfare 2 and when I was like 12 years old. It was fun though. I had a lot of good times, but my favorite video game of all time, we're getting a little distracted here, but my favorite video game of all time has got to be without a doubt 100% Halo Reach. I know a lot of people will say Halo 2 or Halo 3 was their favorite, but I started on Halo Reach when I was like 11, and let me tell you, I put more hours into Halo Reach than I put hours into anything in my life, I think. Maybe besides like growing up playing sports, couch, whatever, but Halo Reach, I'm playing the life out of that game. That game that was like begging me to stop playing it. I got all the way up to like the general rank in there, which was pretty high up because it took a while to grind through those ranks. And I remember I was really big into SWAT, where you could get one shot headshots with a scout. And SWAT, I played that just so much, so much. I was just like, I played so much that I was really good at SWAT. Like I could just pick people off like one shot, one shot, one shot. Um, yeah, Ryan, that sounds something like that sounds fun, right? We could play Minecraft or. All right, let's read on here. The array-based representation of a binary tree, section 832, is especially suitable for a complete binary tree T. We recall that in this implementation, the elements of the tree are stored in an array-based list A, such that the elements at the position P in the tree is stored in array A with index equal to the number of f of P defined as follows. If P is the root of T, then f of P is equal to 0. If P is the left child of the position Q, then f of P is equal to 2f of Q plus 1. If P is the right child of the position, then f of P is equal to 2f of Q plus 2. So what is f of P and f of Q? F of Q is the parent position. So if Q is the position of the parent position of the child, then f of Q is the level number. So the level number of the root is 0. The level number of the left child of the root is 2 times 0 plus 1, or 1. The level number, so the level number is just the index. With this implementation, the elements of T have contiguous indices in the range of O to n minus 1, or sorry, 0 to n minus 1, and the last position of T is always at the index n minus 1, where n is the number of positions of T. For example, in figure 9.4 illustrates the array-based representation of the heap structure originally portrayed in figure 9.1, where we have a root 4C, its left child at 5A, its right child at 6Z. 15K, however, comes in at index value 3. So 9.1 is this figure. Okay, so you go left to right, basically, in ordering them. So then my question is what if you have a none? Like if you have a blank spot? Well, it wouldn't be technically binary tree, it wouldn't be filled, right? Because you have to have either at the leaf one child or none. Okay, so index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 nodes, 0 index, 0 to n minus 1, 0, 12. Perfect. Okay. So then 15K, the parent has a level number of 1, right? So it'll be 1 times 2, which is 2, plus 1 is 3. Then its child is 4. Okay. So I'm going to take this here. this. Um, Tip, right? Read the tree top down, left to right. Top down, left, right. Down. When reaching a new level or a new depth, read left to right. Right. So I'm going to go like this. Let's go screenshot here. I'm going to take a screenshot of this array. Capture. And I'm going to take a screenshot of the array above, of the tree above. Okay, let's copy this. Example. There. And then let's copy this other one. Paste that in. So now if we shift command V, you get that. Cool. That looks really nice. That looks really good. Nice. Guys, if you want my notes here, you can access these in my Discord link below or on my GitHub. That's the same link that'll take you there. All of my notes are there, and you can get access to all these practice problems and this detailed breakdown that I've been doing in kind of simple terms of this jargon. So thanks so much for joining me. Hey Zainab, welcome. I appreciate you for jumping in here and saying hello. What's going on with you? What are you working on this evening? What are you studying? What brings you in? And to all of you guys out there, let me know what you're working on. What kind of programming languages do you write in? What are your goals? Do you want to be software engineers? Why are you learning programming? Let me know more about you guys. I feel like I answer all your guys' questions. Now maybe it's time for you guys to answer mine, huh? Okay. Here we go. Let's keep moving. With this implementation, okay, yeah, gotcha. We read that. Implementing a priority queue using an array-based heap representation allows us to avoid some complexities of a node-based tree structure. In particular, the add and remove min operations of a priority queue both depend on locating the last index of a heap size n. With the array-based representation, the last position is at index n-1 of the array. Locating the last position of a complete binary tree implementation with a linked structure requires more effort. If the size of a priority queue is not known in advance, using an array-based representation does introduce the need to dynamically resize the array on occasion as done with a Python list. The space usage of such an array-based representation of a complete binary tree with n nodes is O of n, and the time bounds of the method for adding or removing elements become amortized. Right? We talked about that last time, so interesting. We provide a Python implementation of a heap-based priority queue in code fragment 9.4 and 9.5. Although we use an array-based representation maintaining a Python list of item composites, we use an array-based representation maintaining a Python list of its item composites. Although we do not formally use the binary tree ADT, code fragment 9.4 includes non-public utility functions that compute the level numbering of a parent or child of another. This allows us to describe, although we do not formally use the binary tree ADT, Code fragment 9.4 includes non-public utility functions that compute the level numbering of a parent or child of another. This allows us to describe the rest of our algorithms using tree-like terminology of parent, left, and right. However, the relevant variables are integer indexes, not position objects. We use recursion to implement the repetition in the upheap and downheap utilities. Okay, so this is what they implemented here. They have heap priority queue, which takes in a priority queue base as the parent class. So we define a non-public parent, which is self j, returns j minus 1 integer division 2. Okay, so you'd get the parent. You just inverse this kind of thing here, right? So you do j minus 1 divided by 2. Then the left would be, to find the left child, j times 2 plus 1. To find the right child, j times 2 plus 2 right here. And then has left, return left, the left data, left j is less than the length of the data. Index beyond. Okay, so you want to just see if it's beyond the length. Has right. Swap just does the swap. Upheap parent. We save parent at each iteration or each recursion. If the j given, which is j in this case is the j is the f of q. So like a root. You have upheap and then downheap. Okay. So then we initialize, but these are the public behaviors now. We initialize self with an empty array. Data is an empty array. Length is length of data. Add, data append the item key value. Then you call upheap. So upheap takes in j, a position. So upheap length of the data minus 1. Okay, so you upheap that last position. Because you append it, right? You added it already to data, so you need to upheap that position, okay? Minimum returns the 0 index. And remove minimum pops that item off, calls swap on the last element and the first node, or the 0 node, and then calls downheap from the 0 position and returns that. Okay. That wasn't too bad. That was not too bad. Just do you have a link or something? Just post it in like the Discord off topic or something. Script Serpent. Unless it's like a long, you might have to upload as like a private or unlisted video on YouTube or something. If it's a big file or something. Right, working on starting the week 0 project right now. I'm probably going to finish this week after my schoolwork. Awesome. Is that the CS50X course you're talking about, Ryan? In the week 0 project in Scratch? Yeah, that one's not too bad. You should be able to get through that one pretty easily. It's just, that basic Scratch, using blocks that kind of make loops and stuff. It really, I honestly don't put too much time and effort into the week 0 one. My advice is to try to get into week 1 as quickly as possible. That's where you really start to actually kind of write and see and start to kind of understand things, and try to actually write, outside of that Scratch. Honestly, you'll never touch Scratch ever again in your life. So it's that scratch is really there for the people that have never programmed before. So try to just kind of throw together at least what I did. I just kind of made some kind of quick, less than an hour game just of a dinosaur eating apples and counting up. So I just try to get through that one quickly because I wasn't really interested in that, and it was fairly, you know. Zainab, I hate to burst your bubble, but my friend, this is Markdown text. I'm not sure if Markdown text derives from like what Markdown was written in. Does anybody know what Markdown was written in to create this type of file type? But I use Markdown so I can have it converted into this format here when it's rendered, right? So it's really nice for reading these notes for you guys. Okay. Yeah, Ryan, you got that. You got it. Yeah, the game is pretty, it doesn't really do too much for you in terms of coding wise. It just kind of helps you get familiar with like loops and things like that. But the week one problem is where you really start to get into C and like Mario less and Mario more. That's really where people start to have to think about, how to actually do the loops in code in C and stuff. So it's a great. All right. All right, let's do a couple more pages here. We're almost to 9.4. That's on 8.5. I don't want to go do that much. Let's read. Let's do two more pages because we have that picture. Let's do two more here and then we'll move on. We are almost at the hour mark, so that's perfect. I'm going to try to make these streams a little bit more dynamic. I feel like I get kind of caught up doing certain things for a little bit too long, and it kind of maybe um, not necessarily bores people, but it just doesn't help to keep attention. So I definitely don't want to be reading for too long or working on a project for too long because people just might get bored or new people might have to stop in and keep asking what's going on, what are we working on, what are we working on. So I think about like every hour we're going to switch it up to a new thing. So we'll do about an hour of reading to warm up, and then we'll do and practice, whether it be practice problems or reading, and then we'll do like an hour of neat code, leak code stuff, and then we'll top off the stream with maybe about a half hour, 45 minutes if we feel of doing practice projects and things like that. So and then of course we'll swap in and out those hours for the CS50X on some days and things like that. Yeah, I did CS50P as my first introduction to programming about 6 months ago, and now we're currently taking Harvard CS50X live on the channel. So if you're wanting to have a resource or a friend or a colleague to take that course alongside and compare notes, problem sets, information, watch lectures with, please join me here. We're doing it live on the channel, completely transparent. So yeah, thanks so much for coming. And Josh, Ailey could yeah, that's right. That's right. All right, table 9.3 shows the running time analysis of a heap-based priority queue. Table 9.3 shows the running time of the priority queue ADT methods for the heap implementation of a priority queue. Assuming that two keys can be compared in O of 1 time and the heap T is implemented with an array-based or linked-based tree representation, right? In short, each of the priority queue ADT methods can be performed in O of 1 or O log n time, where n is the number of entries at the time the method is executed. The analysis of the running time of the method is based on the following. The heap T has n nodes, each storing a reference to a key value pair. The height of the heap T is O log n since T is complete. The min operation runs in O1 because the root of the tree contains an element. Locating the last position of a heap as required for add or remove min can be performed in O of 1 time for an array-based representation or log n time for a linked tree representation. In the worst case, up heap and down heap bubbling perform a number of swaps equal to the height of the tree, right? Performance of a priority queue P realized by means of a heap. We let n denote the number of entries of the priority queue at the time of an operation is executed. The space requirement is O of n. The running time of the operation min and remove min are amortized for an array-based representation due to the occasional resizing of a dynamic array. Those bounds are worst case with a linked tree structure. We conclude that the heap data structure is a very efficient realization of the priority queue ADT. Independent of whether the heap is implemented with a linked structure or an array, the heap-based implementation achieves fast running times for both insertion and removal, unlike the implementations that were based on using an unsorted and sorted list. Bottoms-up heap construction. Bottom-up heap construction. Okay, we'll stop here. This will be a good place to stop before we kind of dive into something newish. All right. Any questions or concerns here on what we read so far in Chapter 9 in Priority Queues? For those that are new here, we've been reading live on stream, word for word, example by example, breaking it down, the entire book, Data Structures and Algorithms in Python. This book you can find online for free, or if you want, you can join my Discord linked below and get access to a roadmap of all of my study resources from the notes you see on the left of my screen to the book you see above me. That's all on my Discord. I provide it for you guys completely free in there, and you can also, chat offline with me and others in there, share your projects, get access to other people's projects, and the like. It's really just a safe space for people to hang out and, say hello. And thank you so much for joining me here. My name is Michael. I'm 26 years old. I graduated college back in 2021 with a degree in human biology and a minor in chemistry. I work as a chemist for a biotech company where I make biological controls used in diagnostics, patient testing verifiers and things like that. I make large batch quantities of serums, blood, urine, things like that in the lab, and those get vialed down and sold off to customers and hospitals. But I've been teaching myself how to program for about 6 months now, just because I found computer science to be really, really interesting. Being a physical scientist, I think it's mind blowing that we've been able to take physical elements and convert them into words on a computer screen that is able to move and be controlled, and then even have us be able to make our own things, which is just completely crazy. So I started with Harvard CS50P about 6 months ago, and then I completed that very part-time over the summer. Then I transitioned and made this channel and started documenting my progress along the entire journey here for the past, about 4 to 5 months since I made the channel. And we are moving along here. So if that's something that sounds like you guys are interested in, then please, consider following along here. And I stream every single day around 7 p.m. So if you have problems, holding yourself accountable and studying and wanting to learn and just keep procrastinating, then consider joining the stream every day just to help, hold yourself accountable and, participate. It's really awesome. Hey Matthew, I appreciate you joining in. I'm just beginning basically with Python, a month in, new to programming. Awesome, dude. This is the right place to be. I highly suggest you take a peek at the Python crash course I have right here behind me. I have this in my Discord, linked below, or the CS50P course. I highly suggest you take those in tandem because I did that and it was really helpful. Hey Hardcoreism, welcome. I'm a young compiler designer, came in to help out. Nice, dude. Awesome, Josh. I appreciate you for coming in. Is it Josh or Josh? I appreciate it. Let me know how I could pronounce that. Thanks for coming in. All right, let's go ahead and move on here. How about, yeah? All right. Let me actually start at chapter 9. All right, push that up. Ya or Yash. Okay, appreciate you. Thank you. All right, here we are. Here we are. Should we try to do the binary search? Binary search, because we're learning about that right now. You are given an array of distinct integers. Sort them in ascending order. And an integer target. Sort it in ascending order and an integer target. Implement a function to search for the target within numbers. If it exists, then return its index, otherwise return 1. Okay, so we're given a list. 4 was the target, and our output was 3. Return its index. Oh, okay. Okay, so we're given an array of integers. So, right, we're given an array of integers, and we need to determine. Okay, let me go ahead and let's open up our Python practice, our dummy folder here. Remove this guy, and let's bring it open. Okay, let's see here. So we have numbers and a target here. Okay. So what do we want to do? We want to search for the target, which is 4, and return its index. Okay. So we need to evaluate a midpoint, right, for binary search. So if it's odd, this array has 6 numbers in it, so it's even. The middle point would be the 2 plus 1 root. Okay, hold on. Let me go to my whiteboard really quick. Oh, whoops. Okay, so just outlining this, we have -1, we have 0, we have 2, we have 4, we have 6, and we have 4, 6, 8, right? So we need to determine a midpoint for this array. So how do you handle the midpoint with binary search when dealing with either an odd or even number of numbers? So in this case, we have even. So we have middle is equal to the length of numbers divided by floor 2, right? To handle the case where it's even or odd. But I think you actually handle that case with if nums modulo 2 is equal to 0, then set this like that. Else it's odd. So we can set middle to the length of the numbers divided by 2 plus 1. Okay, so nums is even in this case. 0, 1, 2, 3, 4, 5, 6. We would do this, we would get 3 back. So we'd get 0, 1, 2, 3. 4 would be our middle, like, rotating point. If it's odd, let's say if we put in another value here of 9, we take the length of numbers divided by 2, which would be, or floored 2, so 9, or sorry, this would be 7 divided by 2, 3.5 floored would be 3, plus 1 would be 4, 0, 1, 2, 3. Do I have this backwards? So if it's even, nums like this, this is odd nums, like that. So if it's this case, the length of the numbers is 7. Floored by 2 would be 3. So 0, 1, 2, 3. And my rotating point would be, so that it would just be this for odd. But then for even, floored would be 3. 0, 1, 2, 3. So I think though that this does have to be within our loop, right? Because we need to evaluate the length of the numbers as we slice numbers going forward. So I want to, actually, let me pull up here. Hey, welcome Ryan. How you doing, dude? Welcome back. Um, do you even need to do this for binary tree? I'm looking at my notes here for that we took yesterday in CS50X on binary tree. And it's saying if the tree is equal to null, return false right away. Else if tree points to number. Doing good, doing good. Trying to figure out the middle here of binary search. So okay, so let's just say for I in the range length of nums, we're going to iterate over it. So now we need to do an evaluation of if number is less than middle, right? So if nums index middle right is, so if our target is less than nums index middle, right, we're going to call if the target is less than, which means it needs to go to the left, we're going to go search return search if we want to do this recursively, return search nums 0 to middle, right? Elif target is greater than nums middle, return search nums index middle plus 1 through return middle 1 plus 1 through, so we need to get the through -1, the last value. Okay. So let me not return search here. Let me just call, or yeah, let's say search for a nums, which is here, and then a target. F, like so. So I don't think I'm handling this middle thing right. So what do I need to say if it's, so if it's odd, we know that the middle is floor. So if it's 0, 1, 2, 3, 4, 5, 6, 7, 7 divided by 2 is 3.5. But that is floored down to 3. So 0, 1, 2, 3. Perfect. So then what do you do for the case of the odd, though? Right? Else target right? So to middle. Yes. Trade. No, so elif target is equal to nums index middle return, right? Else return -1. So if I call search on nums and target of 4, right? nouns. So then we'll say put n here. Boom! Solved it. Woo! Yeah! Now let's try it for an even case. Yo, no way. No way. Oh, didn't solve it. Oh. Maybe not. Zero is returning middle. So I need to return of the new array. Right, because I'm taking a slice every time down. That's the thing. So, oh shoot. How do you return the index from the original array if I sliced it down this whole time? So return, instead of returning middle here, so unfold, return the index. Oh, shoot. Right, so if I gave here, this would give me 6. If I gave, return true. True. If I do 9. Line 16, I can error this here. If the target is less than this index out of range. Hold on. Right, so we can return, if we do that, it'll just give me 0. If I have it, if my target's in there. Because what it's doing is, target 8, what if I do target 4? That'll go through. I just got lucky. I go target is 2. I want index 0, 1. target 0, 0, 1. I go 8. Okay, out of range, middle. Here, so this isn't even. No, this is for even, sorry. There. No. What do you split on an even? This is even. Go 6. Do this again. So then we're I mean, we don't even have a base case really, right? So that's kind of a problem. If n is equal to 1, return, if n is equal to 1, return, okay, if n is equal to 1 and nums index 0 is equal to target, return target, return true. False. If it's not equal to 1. So if n is 0, hey Insomniac, welcome. Appreciate you for joining me here. Just working through this Neet code problem, binary search here, trying to figure it out. I haven't written binary search in a while, and we're trying to remember here. So we take the length, if n is equal to 1 in this case, and is equal to target, return true in this case. Turn index middle, like so. Else, right, if n is divided by 2 is equal to 0. So I think it's this middle case. So this will return that. So if to not -1 up to n. and this value. List. Still get time about them. Here. Oh, okay. So we'll go here, copy this down to here. Return middle here. Now what happened? What does that give us? 0. Turn. Which is an index? 0. Turn. Oh, we don't need this statement. So here, that. Back 0. If n is equal to 1, and numbers index 0 is equal to the target, return middle. So in this first case, n is going to be 1, 2, 0, 1, 1, 2, 3, 4, 5, 6. N is 3. No, n is 6. So middle would be 3. 0, 2. Do you do like this? -1? I know that there's something weird with this middle for one of these cases. So you see -1 here. 0, 2, 3. You want to be here. Turn middle. None. Oh, you can just go through all the way like that, right? Still gives us back 9. So we have, if n is equal to 1 for the length and numbers is index 0 is equal to target, return middle. Return nums 0. So that'll return this none back. elif so we are in the length of the current list. We call search through over on target. So we're getting none here. So if I can't return set of truncate, and that one statement's not true. So what should be our base case? Let me pull up my CS50X notes here. So if so the base case should be if you didn't find anything. So if n is equal to 0, return -1, right? Else go do this all the way down. Elif n is equal to 1, turn so we return on the base case -1 if we don't get anything back. Making search a hat function could help. What is a hat function? Elif n is equal to 1 and n index equal to target turn nums Well, if you're searching one step in the tree at each case from left to right, right, you would need like a count. Is that what you're saying? Like you saying extra parameters. You need like a count basically to count how many steps you've gone down. So you can basically use that count to pull back the nums index, right? But I'm not allowed to do another parameter in this Neet code problem, right? I'm not allowed to put in another parameter for a count to count the recursions so I could basically return the count back for the index on the original number. getting something on line 25. I don't know what a hat function is. A hat function is a function which calls another helper function. Oh, okay. I'm forgetting something here. If it's greater than none's middle or search. Hey Gina, welcome in. How's it going? All right. Okay, so search returns search will return an integer, right? So we need to return so should I not do this recursively then? Should I? So could I just do, I don't really want to exit out of all this, but could I do while so how can we do this iteratively? Search returns an integer. Which happens to be the index of a value, or -1 if not found. Okay, so length and we have target, which is 6 in this case. So 4. So here we go. So I say bool search, which returns true or false. So it was found. If number is less. So what if I just make this for true or false statements first? So I have n is the length of numbers. If n is equal to 0, return false. Right? Else it's not 0. If n n modulo 2. If it modulo 2, it's even, right? So middle is going to be equal. N N2. Okay. So if middle, if nums index middle is less than target. No, target is less than. I like it the other way. Target is less than nums index middle. Then we need to go to the left. So we need to run to the left, walk to the left of this tree. So this will return return nums index through up to middle. Right? Okay, so where's my thing at? Pulling up. So it gives me sorted ascending order. Yeah. So 0 up to middle. Turn search nums target. Hey, Trading Prodigy, how's it going? Appreciate you for stopping in and saying hello. What's going on with you? Yeah, we're trying to do the binary search Neet code problem here. We've been studying it in our chapter 8 in our DSA here and in CS50X. So we are trying to just practice it here, get some practice. I appreciate you for jumping in. So, right, if the target is less than the nums middle, we're going to run search through the 0 up to the middle, right? And else target is greater than nums target is greater than nums index middle, right? We want to return the search function again of nums index middle plus 1 through, like so, and target, right? So then if it's 0, return false. So we need to get middle here. So middle return target return. None still. Dang it. None. Wow, this is a unique way I do it differently. Yeah, interesting. How do you do it, Trading Prodigy? Let me know. Okay, so get a middle. Search tree. So if number is less than the tree, return search. Start. Tree. Number. So do we have a thing? Does this go at the bottom? If, else if. So if, else, if target equal to nums middle. Oh yeah, not middle, right? Return true here. There we go. So now if I do -1 here, true. If I do 0, true. If I do 9, false. Woo! All right, we got it. We got it. Okay, sweet. So now what happens if this goes up to 9? Here, for an odd, true. Now if I give it a 10, false. Woo! Here we go. Nice. All right. Hey, Splix, welcome in. Yeah, I thought about using a while loop. We might have to actually do that here because we're actually not supposed to edit the numbers, right? Which is interesting because we're supposed to return back the index of the original numbers list. It's a wave. Oh, I was wondering what that meant. That's a cool way of doing it. You could have just done like the emoji, the wave. Hey Cisco, welcome in. All right. So then what happens if I return middle here like that? False. So if I give 9, if I return just middle, I get 0. If I return index of middle, I get index 0. So I don't think I can do this recursively, can I? Because on line 20, when returning, do you return the index of the target numbers or the index of the target in some other list? So I'm taking my numbers, I'm slicing from it. Now trying to set left to the beginning of the numbers array and right side equal to. here's the problem. On line 20, when returning, do you return the index of target? What? Yeah, I return the index of numbers in a slice. Yeah, in the slice. Because you have to. I mean, you have to move the numbers array down each time, right? Or you have to like shrink it down in order to do the search. So then we need to bring it back out here, right? We need to unfold it back. So instead of returning true, we hit our base case and we need to unfold this back to the first recursion. Oh. Hey, Helpful Lamb, welcome in. Thanks for stopping by, Splix. Appreciate you for coming in. Return mid for that target. Return mid for the target equals num's middle. So if you return mid here, right, because we're recursively slicing down all the way till our list basically looks as a size of 0 or 1. And once we get to a 1, we do a final evaluation and return a value back. Create a target with num's middle. So, I mean, I am doing it, right? So, if it's less than, it's greater than, I'm doing the evaluation here. I mean, my binary search works. My function works. You guys are tripping. It works for what it's supposed to do, but it's not. Now I just have it returning false and true. Right? So I need it to now return the index from the original list. Hmm. So then should we... Let me go ahead and print nums at each step here. Yeah, it splits it down in half, returns true. So then, there's a final evaluation here. would just do the same thing as 0 there. True. So then, instead of returning a slice, we want to call search on a value. If value so this is going to return this returns the new slice as the value. So I don't want to So should I copy the thing is I'm not sure how to, because I'm breaking this list down and slicing it further and further into a base case of either 1 or 0. I'm not sure how to convert that 1 or 0 back into the original index of the found number. Search for 8. Let's try it. Right. So that gives us the 4, 6, 8, and then the 8. But how can we get this 0 index to translate into n minus 1, which happens to be the last index? So we save the array as a value. Length of value is 3. This is 6. Do you take return the length of nums, return n No, because the length of numbers is at this step is the same. Oh no, n minus val? The length of val? Do you take the difference in lengths, basically? So if this is 3, we want the difference. No, so length of 3 plus n at this current step. So length of 3 plus 3 would be 6 minus 1. No, like that. So in this case, n at this recursive step is 6. 3 gets returned back. It subtracts. So this would get passed to here, subtract for a length of 2, 0, 1, 2, which would be the index, which it is. So we have to do n minus the length of val, like that. Yeah, Zanib says we can, like, we can just get rid of the 0 here. That doesn't matter. So n minus length of val. So at this point in time, the length of val so n at this step, right, is 6 minus 3 at this step, and length of 1 minus 3 would be 2, so would give us the 2. The 2 is returned. 2. Oh. No. Shoot. So, right, if 3 minus 1 is 2, and that equates to that index. You guys can't see this because here's what I got. 3, length of 3 minus length of 1 would give us index of 2 at the 8. Length of 3 minus length of 6. No, we need we need to get a value of 5. So this would be length of 3, length of 6, 2. Length. So n. One, 4. So your original code was good minus lines 23 through 24. Minus lines. Okay, so not that. If middle is the last index, shoot. Well, should we try to do it with a while loop so I don't have to deal with the recursion? I can just return back the numbers with a copy, basically. Because I'm not sure how to retrieve this value back once I've already sliced the list down to its base case. That's what I'm struggling with here. So middle plus 1. I don't think you should use target less than num's middle. You don't think I should use the left case here? Why, trading prodigy? Okay, so let me take this. Go down like this. So while let's go get rid of this. So while middle nums middle does not equal to target, so we have to set the middle initially, right? So we have to say, well, here, right? So that's middle initially. While middle does not equal to the target, while middle does not equal to target, we want to continue would you say while middle does not equal to target, continue if, so we'll take our statements here, basically. If the target is less than num's middle, we're going to not call search, but we're going to do nums a copy of nums I really don't know how to do this this counting part. So let's take a slice through middle. So then if elif target is greater than nums index middle, can I set middle within the loop here, or does it have to be outside? No, it takes it. Okay. right? While middle equals target nums slice or copy slice goes through so if the target is less than nums index middle, copy the numbers array currently for index 0 up through the middle. So what does the loop count tell us then? Because it's doing an evaluation all the way down. So the loop count only tells us the height or the basically the loop count at the end will resemble middle because you're gonna reduce down half of n. So if n is 3, we're gonna have 3 loops to get. If n is 6, we're gonna have 3 loops to go down to base case of 1, of 0 index. So the count only tells us half of n basically. So a count wouldn't suffice for getting that index. Now if target is greater than num's middle, return nums index middle plus 1 through. That's what I did before right here. Search nums middle plus 1 through. That's exactly what I did before. So we're trying to do it with the while loop right now here. So I'm just stuck. So we go here. We set and the middle point go here. While middle does not equal to target, we're going to continually slice a copy of numbers down all over. So that'll give us, oh gosh. The slash slash is floor division. So this will give us the lower round basically. It'll always round down on any decimal. So the thing is I got it to work for true and false, but I just don't know how to return the index associated with the original list intact. Because on each slice, right? Now, before I don't have to take copies really. Because at each slice, I mean, should I do copies of the list each time? Because each time I'm lowering the list by half, right? which doesn't really. Got you, trading prodigy. Yeah. So we're doing the same thing, just kind of different terminologies here, I guess. Right? So my list is being reduced by half each time at so how can I, if I got 8 here, back on index 0 for this recursive list, right? How can I get back up to this list and give 8 at index 5? If I broke down, and I don't want to iterate again and say, okay, uh, can't you just call the function as you're calling it? Because you don't have to break it down to one element. So then back here, right, if on each recursive step I'm slicing down our numbers array. That's a good idea, Brian, is we could use 2 pointers and keep track of the middle at our pointer. So we need a return statement here. So I already wrote this. This works for true and false. This worked, right? So, right, if I have 8 here, this works. Right, for 9, it does not work. False. But I'm not trying to, I wrote it for true and false, but now I need to return back the index of the original numbers list of this value. So I have to return back index 5. But each time I'm calling search on my numbers and slicing my numbers list down until I get to a single case of either n equals 0 or, inferring n equals 1. Um, but returning mid, right? If I return middle, 0, because I break down my list into a single index, right? Just like Zainab said, in his post, is that it goes from -1, 0, 2, 4, 6, 8, 9 to 6, 8, 9 to 9 to true. So I'm slicing this down to a single index. I would remove 18, 19, and then do if target is greater than nums and elif target. Target is greater than nums. I would remove 18 and 19. Why would you remove this statement? This statement wouldn't allow you to traverse the left side of the tree if you remove this statement. What else did I call that again? We're almost there. We got the binary search rote here. We just need to figure out how to actually so what if I call, what happens if I do this? Still 0. So a copy doesn't do anything. Trading prodigy, I'm really not sure what you're talking about. Why would we return the length of numbers -1 if it's to the left? We need to recursively search through the left and the right side. Yeah, sorry. I'll pull up the question here too. Right, this is the question. Oop, get out of here. Okay, so, right, you have value equals search, right? So what happens if I go print val? And return val. So I have to have the target be greater. So the target's 8 in this case. What happens? I get 0, 0, 0 for the val is returned. 0, 0, 0. 0, 0, 0. Oh, here we go. That's right. True, true, true. Print val is returning true. True, none. As if you print. Hey, Brian, welcome in. What's going on, man? Yeah, Brian, we've been moving up. I appreciate you so much for joining here. The guys have been supporting me like crazy, honestly. I really, really, it's quite unbelievable. Where's my cell phone at here? Grab it. See where we're at here on the old sub count for tonight. You guys have really been, pushing us forward. 1248. Thank you guys so much for subbing. We're almost at 12.5 or 1.25K. So thank you guys so much for subbing and for joining along here. Appreciate you guys. Mahan, I don't think we can add another parameter though. Like we can't just arbitrarily add a parameter onto this Neet code problem. I can't just add in another a parameter, right? Like I don't know. Can we? It's all right, Brian. Yours is, you guys are spelled differently. No worries. No, I appreciate you stopping in, Brian. No worries. Thanks for coming in for today. If the search fails, we return false, basically. That's what happens if n is equal to 0 in a base case. Remove lines 24 and 25. And do else return true. That didn't really change much. It's just, right. That just kind of cleaned up the syntax a little bit. So the issue is if the search on line 22 is -1, if the search on line 22 is -1, what should you do? If the search on line 22 is -1, why would this return a -1? This either returns true or false. So if we get to 0, we return -1. We didn't find anything, right? So if I do 9 here, -1, right? But if I do find a value, I return 0, and then do I add a value here and return 0. Plus middle. I don't think that does it either. I guess this. So a 9 gives us 2, not -1. So if middle here would just be 0. So we'd still get 2. So we have to combine it with something at each step in order to basically see you tomorrow, Zanab. Thanks for stopping in tonight. So we return middle here, plus search. So if it's less than, though, we need to go from 0. Stick us back 2 for 9, which shouldn't be there. If I go 0, this gives us back 0. My problem is your middle is not mutating in the first step. Middle plus search, so 0 in this case, plus the search. I go plus n. Put in 2, this should be 0. Put in 4, 0, 1, 2, 3, 8. Middle plus so you have middle. What do these numbers represent? So at the very end of your recursion, your middle equals 0, right? So 0 gets returned plus what? Middle? So 4, 0, 1, 2, 3. No, we don't want to get length of middle. What other variable are there? Middle plus. I mean, we wouldn't want to go target. Do you just add 1? 3, 6, 4. Alright, that's the answer right there. right, I think we got it. So you add middle, but middle is 0 at first, so you add 1, right, at each step as well to basically count down your walk down your binary tree. Because if you remember how you're counting your binary tree when it's represented in an array, the -1 is the root, the 0 is the left child, the 2 is the right child, the 4 is the left child of the 0, the 6 is the right child of the 0, and the 8 is the left child of the 2. So we technically just need to add 1 here so we can increment, and walk down this array through our binary tree. Now if we search as -1 for a 0, that still returns back 0. Go 0, this should give me back 1. If I go 2, this gives me back 2. If I go 9, this gives me back 5. So if temp no, so we have to do some sort of check here, because if I do 10, we still get, oh, so hold up. What's going on here? What is it not like? What is it not like? Int. Oh. Doesn't like this. Oh, it's not returning. Turn middle. So we get 5 still. So if we're getting values that aren't in here, we're always getting 5 back still. So then instead of returning middle, no. Right, so if we have a temporary variable here that houses this, what happens if I print temp here? And I need to return temp. Zero, 2, 5, 5. Let me move this to the bottom so you guys can see. Let's pull up. Oh, you guys could see before. You guys on the right. It wasn't on the far right side of my screen. Sorry. Thanks for bearing with me here, guys. I'm just learning, trying to teach myself this. I've never sat in a formal college lecture for computer science. This has all just been me reading books, trying to learn this stuff from literally never reading code before. So we've come quite a long ways, but we've got a long ways to go. I'm really not in any rush to learn this stuff. I really am trying to just process it and understand it altogether. That's why I'm not like breaking here, cheating for an answer, or stuff. I'm really trying to understand what's going on and solve it. I don't really care about time. I'm not in a crunch. I already have a job as a chemist. I'm not, there's no pressure here. But if so if I run this, we get 0, 2, 5, and 5. So if temp is 0, I should return, because if I give a number that I need, like 2, I get 2 back with a printed. Oh, so let me give an 8 for the higher version. I get 2, 5, and 5. So if I return back 0 for temp, right, besides doing this +1, so you have here, if temp equals to 0, return -1, return temp, like so. So now if I give 8, I give 5. If I go 9, I go 4. Ah, shoot. If I go 10, 4. Now why am I going down? Why am I going down just by doing that? I thought I was at 5 before. I was giving 0, 2, 5, and 5. Now I'm giving 4. So let me print temp here. And then I'm not going to print anything here. Return -1. So I print here, I should be printing out a -1 value, but I'm not. I bring a 0, 1, 4, and 4 for temp here. So temp is 0 on this first case. Yeah, I just tried to solve it with recursion, Mahan, because in yesterday's lecture, what's his bucket, David, he showed us a recursive algorithm for binary tree search using, pointers and stuff. So it was kind of fresh on the mind. So I wanted to kind of give it a shot here. It's all right. We're learning. So why would temp be -1? Like you guys keep saying that. Like why, in what case is temp -1? In no case here am I getting a -1 for my temp. Even on a case where I have a value inside. 0, no temp, it's not even printing. Like that, right? So 8. Temp is 2 and 5 here. Now if I go 9, temp is 0, 1, and 4. For 5. So why is it not returning 0 or -1? Oh, because right. Because you add 1 always on line 22. Yeah, we add 1 always, but middle is 0 no matter what. Middle never goes down to -1 because n is equal to 0. I return -1 there. Yeah, just add the +1 to the return. So the thing is, though, is it's returning -1 at this recursive step. And then feeding that back, though, right? So instead of returning, do I return 1? That gives me 6. Now I can say if to return. Right, if it's 6, so the -1 is return on a failure, right? How can we maintain that -1? Because it's going to be passed back through. So I'm getting 5 here for 9. It's going 0, 1, and 4. Shoot. So if we go print temp here, what happens at print temp? We go 0, 2, 5, and then the 5 is what's given back here. So what evaluation needs to, I don't know, dude. I'm starting to fade here, guys. We're starting to fade. We're crossed over 2.5 hours, so we're starting to fade quick here, guys. Can't you return middle +1 plus temp? So let me do this. Let me print temp here. Temp equals temp plus middle plus 1. So on a -9, or on a 9, a value that's not in here, we get -1 is returned, 0, 2, and then finally output is 5. Right? Because it's the -1 is being returned back onto this function. So we need to say if temp equals -1, just keep returning -1 back every single time. Else return temp. Aha. So now if we go 6, this should give us 4. No. Temp plus 1 plus middle. Ah, here we go. So why? I thought I did this though. I knew this is what we had to do, but I was doing it with 0 because middle was returning 0. Okay. Interesting. It's just an interesting way to think about it because I've only had to do it by giving true or false. I never had to think about it by passing the value back and then building back the original array, basically, like the building back the length of the array step by step. right? Oh, okay, I get it. Because A, you have to add one step for each recursive step that you broke down. B, you have to add the length or whatever of the current array, which is the middle, right? Because you broke it down in half, even more. And then temp is just 0, which is just returned back at the very recursive step. Okay, so now let's take this guy, go in here, place that there, run. No! No! What? Search is not defined. Do I have a type, and I have an error somewhere? Search. Def search. Hmm? Oh, we gotta call self.search. Woo! Bang! All right, we had to put self.search, right? Because we're using a class method here for solution. Using a class method, an instance method. All right, let's submit it. Oh! Yes. Woo! All right, that one took a little bit longer. I got the actual um the true false version really quick, right? I was able to draw up the true false recursive algorithm of binary search pretty easily. So pat on the back for that. Um, I by the way, what does W mean? Just like win, like winning, W wins. W is. I'll have to. If you guys are given W's, you guys also have to reciprocate with L's in the chat when we fail. So you guys can't give me one way. You guys got to hold me accountable. So if you guys, when I hit a test case that fails, L L L L L L L L, that'll make me quit real quick. Yeah. So I did take about an hour or so to have to kind of think through the actual returning of the original index of the array of the found value. But the key takeaway from this, guys, is that I was able to actually implement the true false binary search off the top of my head pretty easily within about 15 20 minutes. Now hopefully we'll cut that down, but I'm quite proud of that. I think that is a successful win in my book, a W nonetheless. um, Now we just had to think about it a little bit creatively and how to actually pass back up the returns and build this array back so we can get those indexes back, um, which we had to do here. So that's the tricky part I had to think about by kind of printing out these arrays at each step and kind of doing a little bit of math in my head. But I am really proud that we were able to do the actual binary search, true or false version, pretty much on our own here. So we are learning something from the class. Yeah, just like Jaw said. Is it Josh? I'm sorry, I forgot, Jaw. What did you say back in the past? Let me scroll up. Is it Ja or Jay? I'm sorry. I really am sorry. Um, please correct me. Um, Yeah, but Mahan, can we get 5 booms? Boom, boom. I always bring up that meme like every stream, but I just love it when the Costco guys are like, "Oh, I'm sorry, David. I'm sorry about your brother that died. Let's get 5 big booms for David's brother. Boom, boom." It's just terrible. Like, where is your common sense? Like, oh my gosh. Thank you, Jay. Thank you, Trading Prodigy. Thank you, Mahan. Thank you guys so much for helping me out with that problem. Honestly, Brian, thank you so much. Magnet, thank you. The other Brian, thank you so much. Brian Hernandez, Brian Hernandez. You guys are both Brian Hernandez. What's going on? Brian Hernandez Gomez and Brian Hernandez Mora. Thank you guys so much. I appreciate you both. You guys coming in. You guys have to make a project together or something. It's like fate. Who else was in here? PJ, thank you so much, PJ. You're awesome. Really appreciate you guys stopping in for that help. Zainab, thank you. You're awesome. Thank you so much for coming in for that problem. You're great. Really appreciate Intel UHD Gaming. You're awesome. Thank you so much for coming in. GGG67UT. Use AI to better explain things you consider. Yeah, I always do that. I really try to preface the AI to not show me any code before I ask it to do anything. I will oftentimes come up with my own answer and then have it refine my answer for me, but I always try to give it my first attempt before I go ahead and just have it do something. And almost 99% of the time, I will preface to not show me code and try to, deduce what it's interpreting, interpret what it's saying in English into my code. So by translating, the English language into English code, it really helps me to learn. So yeah, thank you so much for coming in, GGT. GGG67UT. Magnet says, were you purposely not trying to use a while loop for this? Sorry, I wasn't here for the whole stream. Just curious. Hey, Magnet, thanks so much for stopping in, and thank you so much for your question, actually. So, yesterday in our Harvard CS50X course that we took, we learned about binary, no, of course, in data structures and algorithms in Python that we've been reading live on the channel. Back in chapter 8 was trees, and we did talk about the binary tree and everything in there. And then in CS50X, we were also given some further solidification on in the week 5 data structures that we watched yesterday on the binary tree as well. So just because it was fresh on my mind, I saw this problem within the available options of the Neet code, and I was like, oh, let's give this one a go. And then just because David kind of showed us a recursive approach that used a search algorithm as well for a target and like a tree, it similarly kind of resembled this. So I kind of wanted to try it and get some practice with it. Now, I guess I could have said while middle does not equal target, whatever, keep looping or whatever. We could definitely have done that, and we can definitely try to do that. But I wanted to try to do it with recursion A because we got some practice with it yesterday and exposure yesterday in that lecture and in our book. And B, I just need some more practice with recursion in general. Like I said, you guys, I struggle with understanding what is being returned and then understanding that, oh, I can actually, append or, concatenate or, subtract, whatever. I can do operations on the values that are returned at each recursive step as it kind of unfolds. So that kind of 3D unfolding process, I have trouble visualizing. So I wanted to get some practice with this. So this was a great practice with that. And so I really wanted to grind through it with recursion. Yeah, Yash. Okay, got you. Yash. Okay, thank you so much. Yeah. Big justice. Yeah. Uh, until we reach traversing trees, I'll be here. Awesome trading prodigy. Appreciate you being here. We'll get there soon enough. But I'll definitely need some help there. Thank you so much, Mahan. Misclicking, no worries. V's instead of W's. Um, Recursor Brian Hernandez. My fault. Recursive. Oh, did you spell it wrong or something? Also, pro tip: using a debugger when you're not understanding is a great skill to have. Yeah, I saw your messages. I honestly just need to get some practice, and I'm kind of stubborn with the debugger because I don't know why. It's a tool that's there. I use print statements sometimes, but honestly, I just don't have a lot of experience with the debugger, and I think that's mainly why I haven't been using it. But the only way to get experience is to use the debugger. So it's just I'm kind of in this rock and a hard place where I'm like, okay, do I want to bite the bullet and start using it and learn it, or do I want to? So one of these days or soon enough, I'm just gonna have to just do it and skip over stuff and do the skip over, do the step into, and figure it all out. Um, Lots of chats here. Thank you guys so much for participating. If you guys are here and enjoying the stream and want to know network in the future, please consider following along and subscribing. I would love to talk to you guys in the future streams and connect with you. I stream every single day, studying computer science, mathematics, other those mainly those topics. I really want to go far in this and just continue learning at my own pace. I don't have any pressures of a professor or any sort of TA looking over my shoulder, grading my papers, nothing. So it's really just a chill, pressure-free environment where we can move on from topics when we feel comfortable to move on, and we don't need to skip over things for the sake of just keeping up with a class. We can really take our time and actually, learn these in depth so we can, relay them whether it be for future jobs or in applications in real world or whatever. So thank you guys so much for joining me. My name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company. I've been doing that ever since I graduated back in 2021, so a little over 3 years now. Or the end of 21, 22, beginning of 22 is when I started. So a little over 3 years. I'm a mid-level scientist too, pushing for like a scientist three here within the next year or so, hopefully. I make biological controls, and I've been teaching myself Python and programming for about 6 months now. We've come a long way reading various books like the Python Crash Course, the data structures and algorithms that you see above me that we're reading. We're on page 380. And as well as doing various courses like Harvard CS50P and CS50X. We completed CS50P as our first introduction to programming about 6 months ago. I started the channel afterwards to help document my progress. I felt that there was kind of a disconnect with beginners on YouTube. It seemed like a lot of beginners were, senior level or junior level in computer science and already kind of knew a lot of things, and or were kind of searching and grinding for jobs. And so I wanted to bring like an actual beginner point of view that was not someone that had any sort of previous background in this. So I wanted to show what it was like to really grind through this, really struggle through some of these topics. I don't really care if I look dumb or stupid or don't get the right answer, and you guys do know it. I know you guys help me out and will help me get there eventually. But what really matters is that we get through this and learn the material and absorb it appropriately. And yeah. So sorry about the rambles. Hey JP2417, thanks so much for coming in. You're awesome, dude. Did you complete all of the Python Crash Course book? Yeah, so I completed all of the part one of Python Crash Course. I paired this book with Harvard CS50P to fill in the gaps. It was a great way to fill in the gaps in CS50P. This really helped me build my final project. Learning about lists and help getting those examples and proper ways, iterating and things like that. It just really helps to fill in the gaps. I did not complete part two because I started making my own projects rather than kind of following tutorials. I started making my own live on the channel. We've currently made an inventory tracker system, a task tracker application, which can track tasks over various days and have those tasks expire. And are reported back to you. And then we're also working on right now live on the channel the small business manager that I've been writing towards the back ends of all of our streams. So we've been working on this for the past few months or a few weeks to about 2 months now. Little by little, I'm not in any rush. It's one of the it's probably the largest. It is the largest project I've written so far. It's just in my main script. I'm at over 1,000 lines here. But in my other, I've got classes here that I'm pulling information from. I'm saving across 3 separate JSON files. And so, yeah, it's a pretty good project where we can take in inventory items and expenses, in an instance for each of them, and then cross-reference those across a business and then develop things like revenues for according to various years, or total sales, or various statistics that businesses might need for in reporting the health or status of their business and their revenues and income. So it's a pretty cool program, and we're almost have a working 1.0 version, and then we can start just adding features on once we have the ability to load and manage expenses and items appropriately. Then we can just kind of push it and then start just adding in features for actually calculating these statistics, and just keep adding in new features for the users. So it's almost there. Hopefully in a few short weeks we can get this pushed up, but I've been chipping away at this little by little on the stream here. um, Recursion takes practice. Yeah, this is why I suggest earlier that you stick to recursion, because it's a great practice. Yeah, I wanted to get some practice with it. I definitely needed it. That helped a lot. Yeah, thank you, Helpful Lamb, for helping out me out with that. Appreciate you. David is me. Hey guys, can you give me inspiration in learning object oriented programming? Yeah, you should join my Discord link below. I believe there's actually a chat today where people went back and forth, or maybe it was last night. They went back and forth for a good 20 minutes, kind of describing and breaking down in simple terms OOP for a couple of our members in the Discord, and kind of explaining in simple terms like, oh, think of object oriented programming as like a blueprint for developing some sort of cat or like a bike. And the only things that differ are the physical attributes of said cat or bike, like the color, or the height, or the wheel size, or whatever. So it's just a way of mass producing similar objects that just differ slightly in their attributes. What really helped click object oriented programming for me is I honestly really struggled to understand it and convey that I could represent real world objects with just code. But once I understood that I'm just describing real world things and applying them in code, and that's really the tool that I needed to launch my project making, is I didn't have a way to actually kind of house this information in some sort of structure like a class, to constantly call back on and reuse and house, right? I didn't have a container for this besides just like an array or whatnot. And so once I learned object-oriented programming in CS50P, and I did struggle with it for a good week or two, and then when it finally clicked, after watching some more videos and reading the Python crash course, I just immediately skyrocketed from there, like 2x, like my abilities, because I just unlocked this tool that helped me just build so much more. I was able to make these item classes, make the task tracker classes. Like that's exactly the thing I was looking for to start actually making things. So it was a huge revelation moment when I learned OOP in that course. Honestly, I prefer print statements over the debugger. Yeah, we were using some of those print statements earlier. um, Hey David, how long does it take to learn object-oriented programming? Or I'm always learning as a programmer. Yeah, honestly, computer science is one of those unique, realms where it's constantly expanding, and unlike any other realm in education, it is expanding at an exponential rate. If you think the closest thing you can probably relate it to is probably maybe healthcare, but technology it's the hardest major in my opinion, just because every new year you have like a new class that's being added, a new sector, a new niche, a new technique, or every 6 months, really, something else is being discovered, and so these students are being so spread thin across their time at college. Honestly, I attribute to that why they struggle. Maybe. What do you guys think about that? But along the lines of, yeah, there's always something to learn, right? That's what I was getting at. I'm friends with a few biochemists. Awesome, that's really sweet. Do you know what they do? Python, I'm doing Angela Yu's 100-day course. Dude, 6 months is really good. Yeah, awesome. Thank you so much. Yeah, we've been studying every single day, David. So, it's been a short time relative. 6 months. It's long for the amount of time that we've been doing this, but short in the grand scheme of things. But I have been doing this, for the past 2.5 months every single day. And before that, it was about 3 or 4 times a week. And before that, it was about 2 or so times a week. So I've really ramped up, just because I've developed kind of a big passion for this. And so I will attest, though, that everyday dedication has helped compound these materials. If I watch this CS50X lecture and then I wait a week before completing the problem set, I guarantee you everything I learned in that lecture is gone. Gone. Like you have to, in my opinion, you have to come back the next day, the day after, um, and solidify those materials, or there's just it's just too dense, it's too technical, it's too new, it's I don't know. It's what do you guys think about that? You gotta that everyday dedication really helps compound these topics because I mean, if you learn about a stack and then you don't talk about a stack ever again, right? It's just going to go away, just like anything. But if I learn about a stack, I compound a stack with a queue. I compound a queue and a stack with a deck, right? And then I go back through and I get practice with all three, right? It's just like this package of information that I've just absorbed, right? It's so much more than just one day move on. It's yeah. It takes a lot of time, in my opinion, until you can get your mind in the right framework. Then it's easy. I'm on day 17, but I tried 2 days and I couldn't. Maybe I could move on to day 18, which is the turtle stuff. Also, adding proper types to your code would help you a lot. Like I see you do it sometimes, do it more. Yeah, I need to. You guys are good at calling me out, definitely. I always keep saying this. I sometimes I add types, right? And then sometimes I don't. I like I not that great. Come on, Mike, get better at this. I need to just stick to one way and just do it. I go back and forth of adding types and stuff. Thank you for the feedback. Um, JB, yeah, Mahan, we'll jump in there in just a sec. We've got a lot of questions here people are asking, which is awesome. At what point do you feel confident slash comfortable starting your own projects? Well, to be honest with you, JP, at the very start, when I first made my first project, I did not feel comfortable at all. I did have to use a lot of external resources, asking AI for help and questions, explaining things. Like I said, I do try my best to not have it show me code, so I can really try to write things myself. I try to, interpret what it says in English terms um, you know, into my code. But oh, sorry, I lost my train of thought. You said um, starting your own project. Yeah. So, but that ability to be uncomfortable when making the project really helped project me forward. Now, it might seem counterintuitive, but like really think about it as like a sink or swim. Like if you're not even willing to get in the pool, you are not going to learn how to swim. Like I said earlier, if I'm not willing to even try the debugger, which I currently for some reason I just don't. If I'm not willing to try it, I will not learn the debugger. So it is very daunting, yes, just to go into a blank project and sit there for an hour, 2 hours, 3 hours, just adding a couple print statements, adding a function. It might be a big waste of time, but at the end of the day, it shouldn't be a waste of time because you're a beginner. So any time you're spending in this at the start, you should be getting something back out of it, whether you're learning. Now, that will eventually fade off because this learning is not linear. It does not, translate linear one to one with the amount of hours you put in. It of course takes effort, but at the beginning it does have a sort of linear effect because the information is all completely new. So yes, by just sitting there you're going to be learning technically, but now you can ramp up that increase by actually practicing that and applying it. But you will start to plateau as the learning gets harder and harder and harder, and you start to slow down in terms of what you can take in. But just know that at the start, being uncomfortable in that making that project is what helped me become a little bit more comfortable, right? I got used to being uncomfortable. I got some tolerance to it. It's like that. So, and now I've been able to kind of write these projects and write my scripts here, kind of like I was talking to Mahan offline about it, who's in the chat here. Like I kind of feel like kind of fluent now. It might seem kind of cringe. I'm maybe doing this 6 months, right? But I'm feeling, at least from where was before, a lot more fluent. Like I can sit down, I have an idea for a feature, and I can just go ahead and find out where I want to put it and just start writing, right? I'm no longer thinking about, okay, I have the idea, now how can I actually write it? I just said, okay, I have the idea, now let's just go write it in, just as if I was saying, okay, I have an idea about an essay, let's just go write it in English, right? I'm starting to kind of feel that where I'm starting to become fluent in my tools. They're becoming more second nature, and because I'm not having to think about how I'm going to print this or how I'm going to receive this input, I'm just getting the input, doing the print just off the top of my head, and then I can focus on the actual learning. So once you cross over that barrier, it does help a little bit as well. Um, Also, Python is extremely object oriented. Nearly everything is an object. Yes, that is true. Like in our book, if you're wanting some Python practice and you're a little bit more experienced, I highly suggest taking a look at the data structures and algorithms in Python book. Maybe in chapter 1 and 2, which go over Python. Not introduction because it is a more advanced book. It gives you it just goes over some more intermediate Python, object oriented stuff, like the like more dunder functions, like the dunder, not the initializations, but the other ones. And that could really help you kind of understand object orientation. It is very jargony, like I said. So if you're not used to OOP yet, you need to get a little bit of grasp with it first. But the first two chapters of this book do a really good job of actually kind of showing you that everything is an object, from a list to an int to a str to a dict to it. They're all just classes, and object-oriented classes that override the length function, the dunder length, to take the length of a string versus the length of an array versus the rank, whatever. So they just override these dunder methods to fit their custom class. So yeah, that's kind of what I picked up on. Um, Thank you guys so much for staying with me here. Sorry about my rambles. I just wanted to answer all you guys' questions here. We started off with the first hour with reading chapter 9 in data structures and algorithms in Python, and then we did about another hour and a half of LeetCode code practice. We solved this Neet code problem here, so we did some stuff today. Let me give you a quick demo here of the Small Business Manager before I kind of sign off for today. Like I do say, I do have a 9 to 5 job as a chemist, so I don't stay too late, but I usually try to do about 2.5 to about 3.5 hours every single day just to keep going with you guys. I really just like hanging out with you guys and learning. So this is the Small Business Manager project. Let me go ahead and run here. What's going on here? Um, there we go. All right, so in my Small Business Manager project, right, let me show you guys what's going on here, is you can enter into the project and you have these menus. So I've created this function that's kind of creates these menus for you, and through using while loops, just basic while loops and basic, print notation, I've been able to kind of mimic a GUI here within the CLI interface. So you can create these menus, and you can access the inventory menu. You can transact the inventory, and then you can do expenses, and then you have some settings to override some features. So if we go to the inventory menu, you can add items, find and edit items, and view the inventory. If I go to my items JSON, these are the 3 items we currently have loaded in inventory. If I go find edit item by item number, right, I can pull up item number 1 here. And as you can see, that got pulled up, ACDC band T right here. I got pulled up. So I need to do a little bit more printing up of this printing of the dictionary, but I just have it temporarily just printing the raw dictionary here. But you can actually edit these attributes like the name live within this. So if I make this ACDC new name, right there, ACDC new name. So like if you were selling individual items, you could update these if you made a mistake. Now we can go back to this, and you can add in more items, right? So this also saves this file live after we exit out of that. We can go back to our main menu. We can transact these items, right? So let's say item number 3 here is actually not listed. It doesn't have a listing price or a listing date, and it doesn't have a date sold or a sold price. So this is an item that we can transact. So item transactions, item search, we'll search for item number 3. That pulled up item number 3. We'll list this for sale, use today's date, sure. And listing price, let's say we listed it for $25, right? Boom. that got loaded in right there and updated for 2/6 for the listing date today and 2,500 US cents, right? We're converting whole dollars into cents because we're handling currency in integers, not floats, because I don't want to handle any rounding properties. So we are converting everything to cents and then converting it back to dollars that way. So we can go back to main menu, transactions. Let's do search menu. Let's transact the item number 3 as sold. We did it for sale last time. So if we do one again, we get this error. Item 3 is already for sale. Date listed is this date. It got listed on that date already. So if we do, how about sold? Okay, we can do it as sold. Yes, we'll say it got sold today and it got sold for $50.25. We got a delivery for transportation method and boom, and there it updated. So, which is really cool. Now, it actually didn't ask us our shipping price, which it should have. So, I wonder what's going on there. Let me see. Transact item, ship price. If ship method equals delivery, ship price is none. Okay, got you. So that's why we have it hard coded so ship price equals none. Else you get a ship price. Okay, cool. And so, right, that handles that. And so we can go back to the main menu. We can go to our expenses and do the same kind of thing, adding expenses this time around, right? The expenses have an amount, a date. Those are the two required parameters to get created. Then it has some arbitrary parameters such as a description, category, method, note, and then a number, which just gets created automatically for the user. Now, the user won't know the expense number unless they actually look at this file. Most of the times they're going to be, finding and editing expense by their amount and by the date, because that's oftentimes what the user will know their expenses by. They won't know typically the number or the order in which they bought expenses, because that's just used in my tracking to help pull this in constant time from the key value. But but if they do know the number by looking in the file, they can actually look it up here for the number. So if we go by amount and we say, oh, let's go $75. Boom, we have one expense found with $75. Expense date was 1/30/2025, as you can see right here. We need to update this formatting. Expense number is 1. So we didn't want to show that multiple things were found with $75. We needed to cross-reference that to the date and maybe the number as well, so that if we have multiple ones that pop up here, which they would if they had the same amount, right? So if I did amount for $10, right, instead, so let's go back to the other menu, find edit expense by amount, let's say $10. This is going to pull up 4 expenses that had that $10 amount. So 2, 4, 5, and 6. Now if I go ahead and press 4 to pull up number 6, boom, number 6 is selected, and I pull up this one out of my database. So it's really, really cool. It's pretty much working appropriately for what it does so far. We can just now start adding in, statistics for actually calculating revenues, total expense costs, yada yada yada. We are kind of doing that. So in our business.py file, when we have a revenue instance variable here that's being initialized by an init revenue function upon instantiation of the business. So when the user loads and it reads off of the JSON of their previous business information, it'll initialize a revenue off of the all items that is given, right? So in my initialized revenue, we have a revenue dictionary, and we say for item number and item in the self all items.items. So what that means is we have the item number, and which is the key, and the value, which is just the item itself. I'm just using these variables to describe what's going on rather than key value. In the all items dictionary that was passed in here, .items, so I can get access to each of the key values. If the item, right, if you have an item, right, in this value, if the item's date is sold, try to access and slice off the date sold's first 4 integers for the year and append it and increase for the key and increase the sold price for that key. Except if you get a key error, create that new key with that year and set the price of that year for that item to that year. So what that creates is this dynamic revenue for multiple years. So if I were to go back into my items.json and let's say I say this is sold back in 2024. I edit this to 2024, right? For this sold price. If I exit out of my program now, in business JSON, you see we're at 60,000 here. If I go yes, boom, 2024 got loaded in there with that sold price. So, and it'll continually concatenate or join those prices together for each of those years on initialization. So we'll be able to, do that distinguishing by year for our revenues, which is really, really cool. And then we have a settings menu, which we can edit just some business settings, like the name of the business. And then we can edit the expense settings, like the expense categories and methods. We can have the user actually supply in their own categories and methods that get saved into here. And then we have the same thing happening for the actual inventory settings as well, where they can, edit their sizing within here. And this is where we left off on last time. So tomorrow we'll implement the sizing feature to get saved within this file as well, so that they can override the current sizing that we have, which is just extra small, small, medium, large, whatever. They can override this with whatever sizes that they might see fit. All right. If you guys are enjoying your time here with me and want to, come back later and reconnect in the future, please subscribe to the channel. It's been growing quite nicely, and you guys have been really supporting each other, which is really awesome, and supporting me. I really enjoy coming in and talking with you guys and hanging out every single day and learning alongside you. My whole goal is just to learn as much as I can. We're going to be diving into some advanced mathematics here soon after we finish some of these other courses that we've already started. So we got a lot of material coming, and we're really going to compound this, get into Python machine learning we have back here, fluent Python. So we're going to dive into AI and really, really go into this. So, um, David says, thank you, Michael. You inspired me a lot. How many hours a day or a week do you spend coding? Yeah, I code every single day. I study code and programming computer science topics every single day for a minimum of 2 hours. Today we've been going on, we're almost at 3 hours and 30 minutes. So the stream just makes it easier to hold myself accountable. I will say it's easy to not hold yourself accountable and procrastinate. But by having you guys here supporting me, wanting me to come live, and me also just wanting to learn this, it compounds, and I keep showing up day after day. So I've been doing about 2 hours, 2.5 hours every day for about 2.5 months now, since November. But before that, I was doing it part time, about 2 or 3 times a week. Um, Thanks so much, David, for that question. Yeah, I'm very happy for you. 6 months while being a responsible adult and being this far is just amazing and showcase of your consistency. Thank you so much. You guys are so nice. Honestly, you guys are so, so nice. I really, really appreciate all of you guys. And thank you, David, for that. I just wanted to try to convey that this is possible, right? I honestly, I'm smart. Yeah, I have a college degree. I was able to do well in college pretty easily. And but I I really don't feel that much different than anybody else. And if I can pick this up and learn it, I really feel that anyone can. I'm being 100% honest. When I first learned this in CS50P, I struggled through it. I was watching those lectures not knowing what was going on. I was like I had no idea. Like I was really struggling to take notes, but I just wanted to learn it. I did not want to be defeated by it. I made it a personal goal to really try, and I stuck with it. Becoming fluent in programming is one of the single most empowering feelings. Yeah, I really am starting to feel that, where I'm no longer slowing down by thinking about how I'm going to do it, but I'm mainly thinking about just you know what I'm doing rather than like how I'm doing it, right? Thanks for coming in, Sticky Grows. Appreciate you for jumping back. Nico says, not to stir up a whirl, programming is so empowering, but I feel how do you someone can AI code? AI makes programming go faster, but if you're too reliant on it, you'll never get good. It looks more nicely to use a tool. Yeah, the math never ends. Sick, I'm getting into code myself. Awesome. I want to learn how to code an interactive website. Good aesthetics too. That sounds really awesome, Nico. Well, you should join her on here and we can learn together. Yeah, yeah. So if you're having struggles with consistency, just throw the stream on in the background, and every single day, just throw it on and hold yourself accountable. Like you don't have to be directly looking and following along with what I'm doing. If you're more advanced or less advanced, and you're learning, newer things or whatever, you can just have it on in the background just to hang out. Like we're in like a library session, hanging out in a study room together. Yeah, Nico, you should look into the CS50X course that we're doing live right now on the channel. So I've been completing that live week by week on the channel. We just completed the week 5 lecture yesterday. All right, you guys, it's 10:45 for me. I'm going to hop off here. We streamed for just under 3 hours and 30 minutes today, so a really, really good study session. I got some good practice with data structures and algorithms, reading more on priority queues here on page up to 380 now. We got some practice really understanding heaps and understanding how to, traverse through binary trees and understand, what's happening with heaps and how to actually replace nodes when you pop off the base or the root in the in the priority queue. So we learned about that today, which is really awesome. And then we did a neat code problem. Um, we did the binary search one to help compound that. We were able to really quickly get the solution for the true false binary search, but we struggled a little bit with actually implementing that little feature of returning back the index of the appropriate of the actual original array. So we had to think about that edge case or that case and kind of convert our true false binary tree into returning those values rather than true false booleans. So which was really good practice. And then we kind of went over a little bit about our small business manager while I answered some questions. But tomorrow, you guys, we'll take a stab at, I think we'll do some more reading. We're going to do some more reading, do another leak code practice problem, and then maybe start on week 5 problem set for CS50X on data structures. So remember, after every week, they have a problem set that we need to complete. So we will probably take a stab at that either tomorrow or on Saturday. And then probably move on to the next lecture from there this weekend. So we're really, really moving along. We've only been doing it for a month now. We started January 1st and we're over halfway done with the course. So right on track. So thank you guys so much for joining me here. Join the Discord and chat with me offline. What time do you start streams? I stream every day around 7 p.m. PST. I will announce my streams in my Discord link below. So if you want access to all of my study resources like the books you see, I have PDF versions of the books you see, from my live notes to my live coding to my projects to my practice problems, everything that can be found in my Discord. If you have any suggestions for content you would like to see, whether on the channel or in the Discord, please message me. I'm always open to your suggestions and making sure you guys are enjoying your time here with me. But thank you guys so much for stopping by. I'll see you guys tomorrow. Give yourself a pat on the back for staying here and working and improving on yourself and your education. This is really about you just as much as about me learning. You guys are learning right alongside me here, improving on yourself, your education, whether it is you're learning new things or just solidifying old topics. But anyways, that's enough for my rambles. I'll see you guys tomorrow. Message me in the